Hello everybody, I would like to talk about a new subject, and the title for this subject is how to perform the Anova Two Factor without replication in Excel. In a previous presentation, I have talked about the Anova Two Factor with replication. You can simply return back to it. In this presentation, I would like to talk about the case that is without replication. Without replication is simply means that we have only one observation for each combination or each group of the experiment. We don't have more than one observation or one sample for each combination. This is the question that we will deal with in order to understand how to use the Excel to perform the Anova Two Factor. We have an experiment was performed to determine the effect of 4 different chemicals on the strength of a fabric. So here we have one of the experimental factor, which is the effect of 4 different chemicals, which is the treatment. And the dependent variable is simply the strength of a fabric. These chemicals are used as part of the permanent press finishing process. We use 5 fabric samples were selected, and the experiment was run by testing each chemical type once on each fabric. So we have here 5 different types of the fabrics, fabric 1 till fabric 5. We need to examine the effect of each of these chemicals on each type of these fabrics. The data are shown below. Test for the differences in means using Anova with significant level alpha equal to 0.01 by Excel. So these are the records we have for our question. Simply, first we have this factor, which is the treatment, and this treatment has 4 levels, chemical A, chemical B, chemical C, chemical D, and the second factor is the fabric type, and this factor has 5 levels starting from fabric 1 and fabric 2 till fabric 5. What do we have? Records inside this table represent the strength of the fabric after performing the experiment. For example, this observation or this record here represent the use of the chemical A on one experimental unit from the fabric 1. So here we have only one observation or one sample from fabric 1. It is treated by chemical A, and after the finishing of the experiment, the measure of the strength of this fabric has been done, so it is measured to be 1.3. Let's start understanding some details about the question before starting the So these are the data we have. First of all, regarding the first main factor or first variable, it is the treatment. So this is the first factor. It is the treatment. And the second factor or variable, it is the fabric type. So this is the second main factor. Regarding the dependent variable, it is simply the strength of the fabric. So we need to test the effect of 4 chemicals and 5 fabric for the strength of the fabric. The number of levels of the first main factor, which is the treatment, we have 4 levels starting by chemical A and chemical B, chemical C, and chemical D. So number of levels for this factor is simply 4. Regarding the second factor, the number of levels for the second factor, which is the fabric type, as we have 5 types of fabric, so we have 5 levels, which are fabric 1 and fabric 2, fabric 3, fabric 4, and fabric 5. And this point here facilitate the understanding of the meaning of no replication. So number of observation for each combination between the chemical and the fabric is 1. For example, this value here, which is the strength of the fabric, is done on 1 experimental unit or 1 sample only. So this is the meaning of the without the existence of the replication. Let's also understand the hypothesis of the experiment. We have 2 sets of the hypothesis, one for treatment, which is the first factor, and the second is for the fabric type, which is the second factor. Regarding the treatment, we have the null hypothesis, which state that the mean after using chemical A is the same as the mean after using chemical B. This is B, the same as the mean by using chemical C, same as the mean after using chemical D, or simply we can state that all means are the same or are equal. Regarding the alternative hypothesis, it states that at least one mean of the treatment is different from other. Regarding the second factor, which is the fabric type, the null hypothesis states that the mean for fabric 1 is the same as for fabric 2, same as for fabric 3, same as for fabric 4, and same as for fabric 5. Or simply all the means are the same, while the alternative hypothesis states that at least one mean of the fabric is different from other. So we need to test these sets of hypotheses by the analysis of Anova Two Factors without replication using the Excel. So these are the records for our experiment. We have 4 treatments and we have 5 fabrics. First of all, you should ensure that the data analysis tool pack has been already installed in the Excel. You can return back to a previous presentation. You can easily do it. Anyway, first of all, we click for the Data tab. Then at the right, we have the Data Analysis. If you click the Data Analysis dialog box appears, which simply contains many analysis tools. For example, we have Anova for single factor, Anova Two Factor with replication. These 2 analysis tools has been used in a previous presentation. You can simply return back to it. Now we need to use this new tools, which is Anova Two Factor without replication. So simply click OK. First of all, this dialog box asks you about the input. He asks you to select the data you have. Of course, these are the data. They are selected. Notice that the data or the cells are selected with the labels or the titles of the 2 factors and the levels of the 2 factors. So it includes the labels. So there is a tick on labels. So the input range is from cell C3, this cell, till the cell H7. Regarding the value of alpha, the default value in Excel is 0.05, but simply you can modify it. And we need it to be 0.01 as stated in our question. Regarding the output, here he asks you about the location of the output. If you want the output to appear in this same sheet, simply select the first choice. If you want to appear the output in another new worksheet, you can select the second choice. And finally, if you want the output to appear in a separate new workbook, you can select the third choice. So let's select the first choice and let's identify the cell that the output will appear from. So let's select this cell, which is cell J2. So you can click enter. So now he specify the cell for the output. So click OK. So these are all the results for this analysis. So this is the title of the analysis. It is Anova Two Factor without replication. Here in this table, we have some descriptive statistics for the levels of the two factors. For example, regarding chemical A, we have 5. This is chemical A. We have 5 observational units, 1 in each combination. The sum of these records is 5.7, so the average is simply dividing the sum by the count, so it's 1.14, and also the variance for chemical A. Same for chemical B, chemical C, chemical D. These are the record for the chemical B. These are the 5 records for chemical C, and these are the 5 records for chemical D. And also we have some records or summary for the 5 fabrics. For example, fabric number 1, these are the records. We have count 4. Regarding the sum, it's 9.2, so the average is 2.3, and this is the variance for fabric 1. Same, we have for fabric 2, 3, 4, and 5. This is the records for fabric 2. This is the records for fabric 3. These are the records for fabric 4. And these are the records for fabric 5. Below we have here the Anova result. Regarding the source of variation, we have 2 factors. First, we have the rows, and rows here simply represent the first factor, which is the treatment. And regarding the second source of variation in the columns, which is simply the fabric type, and we have the error, and we have the total. So we have here the sum of square for the first factor, and for the second, and for the error, and this is the total SS or SS total. Here we have the degree of freedom for the first factor, which is the treatment. We have 4 levels, so the degree of freedom for this factor is simply 4 minus 1, which is equal to 3. Regarding the second factor, which is the fabric 5, we have 5 different types of the fabric, so 5 minus 1 is simply equal to 4. And this is the calculation of the SS for the error, and these are the degree of freedom for the error. Simply multiply the degree of freedom for the first factor by the degree of freedom for the second one, and the total degrees of freedom is simply 19. These are the calculations of the mean square. For example, the mean square for the first factor, which is the treatment, is simply dividing the SS by the degree of freedom. And for the second factor, simply we divide the SS by the degree of freedom, so we get the mean square. Again, the same for the error. Regarding the F, or the calculated F, for the first factor, simply we divide the mean square for this factor by the mean square of the error. So this is the value of F for the first treatment. It is about 75.89, while for the second factor, which is the fabric type, the value of F can be simply got by dividing the mean square by the mean square of the error, and the value is about 21.11. These are the probability value, and the probability value is simply the area right to the calculated F. And in the last column, we have the value of the F critical. The value of the F critical for the first treatment is 5.95, and for the second factor, it is 5.41. So we need to interpret or to make and draw conclusions from these results. So we can simply do it. For example, for the first factor, which is the treatment, the value of the calculated F is 75.89. It is significantly greater than the value of the F critical, which is 5.95. So for the first treatment, we reject the null hypothesis and accept the alternative one, which simply means that one of the means at least is different from the others. Regarding the second factor, also the value of F is greater than the value of the F critical. So for the second factor, also we reject the null hypothesis and accept the alternative one, which means that the means for the 5 fabric types, at least one of these means is different from the others. Another way to interpret the summary here is simply to check for the probability value. Notice that the probability value is about 0 if we try to round this value to some few decimals. So for the first factor, the p-value is less than the significant level, which is 0.01. So directly we reject the null hypothesis and accept the alternative one. And for the second factor, the probability value is about 0 if we try to round this value up to few digits. So the p-value for the second factor is less than the value of the significant level. So we reject the null hypothesis and accept the alternative one. So this is the interpretation for the result we have in the Anova table. Let's try to change the value of the significant level. Instead of 0.01, we need to modify it to be 0.05. So what will happen? What do you think will happen if we try to change the value of the significant level instead of 0.01 to be greater, to be 0.05? Do you think these calculations here will be different? Or the value of the F critical? Notice the meaning of the F critical is simply the value of F on the F distribution table, that the area right to this critical F is equal to the determined value. So if we try to increase the value of alpha, so the area should be greater, so we should return back the value of the F critical. So what will happen? Let's try this again. So again, we have here the data tab, the data analysis. Of course, he will give you the last option you have selected. So, okay. Of course, he selected the last option. So these are the input records with the titles and the headings of the levels of the two factors. Now we need to change the value of alpha to be 0.05. And of course, we need to change the the selected cell so that the output will appear. So we need it to be, for example, here. So we select the cell J24. So click enter and OK. So these are the summary for the levels of the two factors. Of course, nothing changed here. But regarding the Anova result, again, we don't have any change for this value. The only change is the F critical. Notice for the first factor, now the value of the F critical becomes 3.49 and it was 5.95. For the second factor, it becomes 3.259. And for the previous analysis, it is 5.41. Of course, because we reject the null hypothesis in the previous analysis, so the chance here becomes greater. So again, the value of the 2f is greater than the 2f critical, or the value of the probability is less than the significant level. That's all about the using of the Excel in order to perform the Anova Two Factors without replication. Thank you for your watching and goodbye.